To drive an SoC to tape out with high confidence, you need to be able to know on many dimensions that you're making progress. You need to know that your architectural issues are being closed, your requirements issues are being closed. You need to know that your verification is proceeding along, that your coverage is coming in line. You need to know how your bugs are doing. And so leveraging the environment, getting that CPU farm put to work, maybe even figuring out a way to multiply your CPU farm by a factor of 10 and know that you can productively take advantage of it, that's going to help with the complexity. It's going to allow you to actually trade CPUs for bodies and get the work done, even in some cases with lower head count. So these techniques are useful. Personally, I would employ them again, but there are some things that I would do differently than I did the last time that I had a chance to work on verification of an SoC. I would use an environment that was easier to use. So the complexity that we had was fine. It was justified by the chip we were working on, but there's so much that's happened in open source web environments in the past 5 years that this can be made simple enough that it becomes productive even if a single engineer is going to be running 5 tests a day. Having that tracking is worthwhile. So, for example, there are some Python packages that I think do Web 2.0 database-backed platforms, Ruby on Rails. There are some others as well. There are some out-of-the-box open source test result gathering packages as well, I think on Veripool. So rather than any type of PHP or web coding, wikis are a much better way to publish the team's information and stay in sync. And then finally, the really exciting thing, and this is, I was talking to somebody at Google who had this idea. If you look at the effect that social collaboration and tagging have had on the web, and think about our environment. I mean, we've been doing tagging for decades. We file bug reports. Filing a bug report is like social tagging of a test. Hey, cool test, check this out, right? But bug reports are not always filed. It depends on the state of mind of the designer, the state of mind of the verifier. It depends on stress. It depends on lots of things. It depends on when the decision is made that a bug really was occurred. So if you lower the bar on what it takes to start tracking chatter on these results, if you put in line some type of tagging, hey, Greg, would you take a look at this? This doesn't look like a bug to me. And capture that sort of social dialogue around your test observation workspace. That's kind of like bug reporting, but it's a lower temperature activity, and people are much more likely to embark on it. And it's one more thing that can contribute to your knowledge of your product status and readiness. So definitely open for any questions. Greg and I are available. We love this topic. Definitely contact us if there's anything that people want to talk about. Going once? Okay. I'm going to ask again. Are there any questions? Mike, ask me a question. Okay.
Can you give us an example of some of these open source packages you're talking about? Just the names of them?
Sure. So, the one that we use is called Ruby on Rails. And what's neat about Ruby on Rails, Ruby is kind of like object-oriented Perl. And Ruby on Rails, Rails is a package that goes with Ruby. And what it'll do is it'll take a database table and your script, it just feels like a data structure that's already got its values in it. You don't have to program the script to tell it how to talk to the database. You don't have to tell the script anything about the database. It just kind of knows what's in the database, and you can.
But if people taking a framework like Ruby on Rails and put something on top of it, scripts or whatever, using that as the implementation language, so to speak, that says, here's something where it's really more catered to this type of things you're looking at, test coverage.
Yes. I know a group of people who do exactly that. Sorry.
The open source ones are talking about.
Yes. So Veripool, Wilson Snyder's Veripool has got some stuff, and there's some coverage information there, and there's some test tracking information there. I know companies that are doing it internally, but what I meant by open source stuff was just kind of like Ruby on Rails. Yeah, I'm sorry.
Yeah. I don't work for a vendor. You were clearly ahead of the curve, but while you were doing that, the vendors were producing coverage databases with APIs. Do you have any comments on what you think the relevance of what they've done is, whether you have to use that or merge that in?
Certainly. So there's an open source, I don't know if it's an open source effort. There's an effort by Accelera.org for the universal coverage.
Universal coverage API, browser.
Yeah, UC API, something like that. Where so coverage databases are hard. If the vendor wants to handle a coverage database, kudos. Now there are some areas where the vendor's coverage database might not be completely helpful. That's if you're working in System C, or if you're in the QA lab, the quality assurance lab. And so there are cases where you're going to be responsible for your own coverage, depending on what languages you're using. So the UC API, I think the Accelera effort on the coverage API, I'm personally hoping that expands into ways to handle coverage, say, just in System C, for example. But no, definitely relevant, important stuff, but needs to be diversified to handle the different levels of implementation that are going on.
Yeah, on the big project, about what percentage of the budget was spent on the infrastructure overhead for this, and how do you think that would scale down to smaller groups?
Yes. The particular implementation, so on a project of the size that we are on, what percentage of the budget was spent on this infrastructure and how would it scale down to smaller groups? The QoS effort was not a huge team, less than 20 people, less than 20 people. Basically, most of the environment that we're talking about there was managed by one person. And, but then, even then, it was too much. It was too hard. And so there were some poor choices made. At the time, the idea was, wow, SQL, it's going to save us. But there's quite a lot of work to move data to and from an SQL database without help. And so I think that by using some of the open source packages that access databases, I think that work can be brought down into line. So what percentage of the budget, it would be less than 5% of the budget was put to managing that database environment. I'm not necessarily counting what it took for people to learn it, but let's assume that time made itself up in other ways. But to make it useful on a smaller team, I think it would be, what do you want to achieve? So start with the lowest hanging fruit of capturing your test results. Just what test was run, whether it passed or failed, and what the seed was. Maybe time of day and users, 5 parameters. That's the type of thing you can code up in Ruby on Rails in 20 minutes. And you can have that information stuffed into the database at the end of every test. And then you have it. And it's being collected, and maybe you don't use it on day one, but when you need it, it's there. Or if you want to augment it for also storing some coverage information, maybe just the coverage information you're trying to achieve, special assertions that are ones you're really looking for, as opposed to all your assertions, which would be a bigger problem. So starting small is definitely the secret, I think. And you can, I think, one person can get a return on investment with a low enough bar on what they're trying to get.